Hello students, welcome back to our classes. This lecture is mainly aimed at giving you some idea of arithmetic progression because as you know there is a webinar by Dr. Chantal Aishram of ISI Delhi which we have organized in collaboration with ganitsora.com. So the lecture is on 7th July and many of you have already registered for it. And those who have not registered can also register themselves soon, because the last date of registration is 5th July and we have already received more than 400 registrations from all over India. So this will be quite a very good lecture, okay, and you will get to learn some new things at least. So many of you may not have idea about arithmetic progression, which Dr. Chantal Aishram will be discussing about. He will basically discuss about prime divisors in an arithmetic progression. So I don't know which things he will be discussing exactly. So since there is an arithmetic progression involved, so I thought of giving you some idea of arithmetic progression. Okay, so you can have a look so that you can understand the lecture better. Okay, so let us begin. An arithmetic progression is a sequence of numbers, okay, which are of the form a. Okay, the first term is a, the second term is obtained by adding d to a. Okay, d is another number, so both a and d are fixed. The first term is a. If you add d to the first term, you get the second term. If you add another d to the second term, you will get the third term. If you add another d to the third term, you will get the fourth term. Okay, so that way each term is obtained by adding a d to the previous term. Okay, so that is how we obtain an arithmetic progression. Okay, so a sequence of numbers of this form, a plus d, a plus 2d, a plus 3d, a plus 4d. Okay, next will be a plus 5d. Okay, is said to be an arithmetic progression. Okay, here a is called the first term and d is called the common difference. Okay, why it is called common difference? Because the difference between any two terms, any two consecutive terms, is always d. Okay, because each term is obtained by adding d to the previous term. Okay, so obviously difference between two successive or two consecutive terms is always d. Okay, so this is what I have written here. Note that any two successive terms differ by d. Okay, so each term is obtained by adding d to the previous term. So in general, if we talk about the nth term, say if n equal to 1, then it is the first term, right? If n equal to 2, it is the second term. So in general, we say it's nth term, nth. Okay, so the nth term we denote it by tn, and if you just observe what is the first term? First term is a plus first term is a, second term is a plus d. Okay, third term is a plus 2d. So the nth term is actually a plus n minus 1 into d. Okay, so that's the general term or the nth term of an arithmetic progression. Okay, so what will be the 100th term? 100th term will be a plus 100 minus 1 into d, that is a plus 99d. Okay, so let us see some examples of arithmetic progression. The simplest one is this, the set of or the sequence of natural numbers, right? 1, 2, 3, 4, 5, 6. Okay, so the first term is 1 here. What is the common difference? Common difference is also 1. If you add 1 to 1, then you will get 2. If you add 1 to 2, then you will get 3. If you add 1 to 3, you will get 4. Okay, so that way the common difference is 1, right? So here I have written a equal to 1, d equal to 1. So what is the nth term here? From this sequence itself you can understand it's n. Okay, first term is 1, second term is 2, third term is 3. Okay, it's just the counting numbers. Okay, so if you put it in this formula also, you will get tn is 1 plus n minus 1 into 1, so that is 1. So here the nth term is n itself, right? Let us see another one, say minus 5, minus 1, 3, 7, 11. Okay, this is also an arithmetic progression where a is, the first term is minus 5, second the common difference is 4. Okay, so if you add minus 5 4 to minus 5, then you will get minus 1, the second term. The third term is minus 1 plus 4, that is 3. Fourth term is 3 plus 4, that is 7. Okay, so that way it goes on. If you put it in this formula, the nth term is 4n minus 9. Okay, so you can put n equal to 1 and see, you will get the term as minus 5. Right? If you put n equal to 1, it's 4 minus 9, that is minus 5. If you put n equal to 2, it is 8 minus 9, that is minus 1. Okay, so the general term is 4n minus 9. Okay, and yeah. So this one 10, 8, 6, 4, 2. Okay, so it is not necessary that in an AP the terms will keep on increasing. Okay, in the earlier example we have seen the terms are keeping on increasing, but it's not necessary. If the common difference is negative, in that case the terms will keep on decreasing. Okay, so a equal to 10 and d equal to minus 2. So in that case the nth term is 12 minus twice n, 10 plus n minus 1 into minus 2. Okay, so that is 12 minus twice n, right? Similarly the common difference may not be integer. Okay, it can be any number, any real number. Okay, so we can have arithmetic progression of this type: 1, 3 by 2. Then, so what is the common difference here? Common difference is half. You keep on adding half, it's a arithmetic progression. So here the nth term is n plus 1 by 2. Okay. Okay, so let us see some simple examples which are usually done in arithmetic progressions chapter in HS first year, and those who are having advanced mathematics, probably you have done it in class 9 or 10. So which term of the AP, this 3, 10, 17, okay, 3 terms are given, so it's an AP is 703. Okay, so we have to find which term. Okay, that means the nth term, we have to find the value of n for which the nth term is 703. So from the given information we can write a equal to 3, because the first term here is 3. The common difference we can write it as 7, so d equal to 7, and let tn equal to, so let us suppose that the nth term is 703. So you put the formula here, a plus n minus 1 into d equal to 703, right? So we put the values of a and d. 3 plus n minus 1 into 7 equal to 703, and then solve it. So 3 goes to the other side, it becomes n minus 1 into 7 equal to 700. So n minus 1 is 100, that is n equal to 101. So 101th term is 703. Okay, so while doing this type of problems, if you somehow get n as a fraction or means n as anything other than a positive integer, okay, then either your calculations are incorrect, or the AP does not have a term of this type. Say if I suppose I get 101 by 2, okay, in that case we can conclude that the arithmetic progression does not have a term which is 703. Okay, so your n should always be a positive integer. Okay, n should not be negative, right? Okay, so let us see another one. The 100th term of an AP is 100, right? And the 100th term of an AP is 100. Okay, if the first term is 1000, what is the common difference? Okay, so first term is 1000, a equal to 1000. 100th term, so we are talking about n equal to 100, right? We do not know what is the common difference, so d is question mark, and we know what is tn. The nth term is 100, right? So 100th term is 100. So a plus n minus 1 into d equal to 100. So this will mean that 1000 plus 100 minus 1 into d equal to 100, and then from here you can just solve it. D comes out to be minus 100 by 11. Okay, so this is your common difference, right? Okay, let us see another type of problem. How many 3-digit numbers are divisible by 7? Okay, you have to find out how many 3-digit numbers are there which are divisible by 7. Okay, so the smallest 3-digit number divisible by 7 is what? 105, right? The smallest number of 3-digit is 100. Okay, so starting from 100, 101, 102, 103, 105 is the smallest 3-digit number which is divisible by 7, right? And the largest 3-digit number which is divisible by 7 is 994. Okay, all of you have done this type of problems in your class 5 or 6, I think, right? What is the largest number of say 5 digits which is divisible by 11? Okay, what we do, you consider the largest number of 5 digit 99999. Okay, 99999, and then you divide by 11, and whatever is the remainder, you subtract that remainder from 99999. Okay, then you get the largest number of those particular digits, which is divisible by, say, 11. Okay, so in this case also you can find it out easily. To find out the largest number of 3 digit which is divisible by 7, what we do, we divide 999 by 7, and you will see, you will get the remainder as 5. So if you subtract 5 from 999, the number is 994, and 994 is exactly divisible by 7. Okay, so that way you can find out. So other numbers divisible by 7 are obtained by successive addition of 7 to 105. Okay, say the first number which is divisible by 7, first positive number, say, which is divisible by 7 is 7 itself. What is the next number which is divisible by 7? It's 7 plus 7, that is 14, right? And the next number again which is divisible by 7 is 14 plus 7, that is 21. Okay, so what we are doing is, to get the multiples of 7, we are just keeping on adding 7 to the previous terms. Okay, so this is what exactly we do. So ultimately multiples of 7, they form an arithmetic progression, nothing else, right? Not only 7, multiples of any number, they form an arithmetic progression. Okay, so yeah, of course we have to fix the starting point. So here in this particular case we have fixed the starting point as 105. So we are counting all the multiples of 7 starting from 105, right? So what is the next multiple of 7 after 105? It will be 105 plus 7, so that is 112. Next will be 119. Okay, that way it will continue. So it's an arithmetic progression with first term 105 and common difference 7. Okay, so let there be, so now I need to find out which term is 994. Okay, for which value of n I will get the term as 994. This is exactly what we need to find out. So the problem reduces to this. What was our original question? How many 3-digit numbers are divisible by 7? Okay, so here just we are using the concept of arithmetic progression. So here the first term is 105, right? Common difference is 7, and the nth term is 994. Okay, so Tn equal to 994, and from there you just put these values, right? And n minus 1 equal to 127, so n is 128. So there are exactly 128 3-digit numbers which are divisible by 7. Okay, so you can find it very easily. Next is how to find out the sum of n terms of an arithmetic progression. Okay, so excuse me. So this is a very historical problem. This problem was given to the great mathematician Carl Friedrich Go, and he solved it in a very short interval of time. Okay, the thing was that his teacher asked him to, as a punishment, his teacher asked him to find out the sum of the first 100 natural numbers, 1 to up to 100. Okay, so he solved it in seconds. So what he did was, he wrote 1 to up to 100 in one line. In the next line he reversed the order and wrote it from 100 to 1. Okay, and then he added term by term. So each of the terms became 101. Okay, each terms became 101, and he could find it out easily. Okay, so this is quite a historical approach to finding out the sum of n terms of an AP. So we do it this way. So what are the first n terms? One term is, first term is a, second term is a plus d, the third term is a plus twice d, nth term will be a plus n minus 1 into d. I need to find out the sum of first n terms. Okay, so what I do, I write this sum in the reverse order. Okay, as equal to, you write the last term here first, a plus n minus 1 into d, then the next term, previous term, that is n minus 1th term, is a plus n minus 2 into d, like that. Okay, and then you add both sides. Okay, so here s plus s is twice s, and if you add this 2, you will get twice a plus n minus 1 into d. If you add this with this, then you will get twice a plus n minus 1 into d, right? N minus 2 plus 1, it's n minus 1 into d. Okay, so you keep on adding this one with the next one, then you will each term you will get it as twice a plus n minus 1 into d. Okay, So how many such brackets are there, or how many such terms are there? There are exactly n terms here. Okay, so if you add a single thing or the same quantity n times, then you will get n times of that quantity, right? So x plus x plus x up to n times. So what is the result? It's nx. Okay, so it's nothing but s equal to n into or n by 2 into twice a plus n minus 1 into d. This is the sum of first n terms of an AP. Okay, so there are some particular cases. This result we have used it several times also, and most probably in class also I told you sum of first n natural numbers, 1 plus 2 plus 3 plus 4 up to n. Okay, what is that? So we write it in a short form as this using the summation symbol. This symbol is called the summation symbol, sigma. Okay, summation, it is read as summation r goes from 1 to n. Okay, so the value of r starts with 1, the next value is r equal to 2, next value is r equal to 3. Okay, this way it goes on up to n. Okay, and what is added? This expression is added. Okay, whatever expression is there, this expression is added. Okay, so if you put it in our formula here, then you will get it as n by 2 into n plus 1, or n into n plus 1 by 2. Okay, so this is the sum of first n natural numbers, right? From this we can also make a deduction, sum of the squares of first n natural numbers. Okay, so the squares of first n natural number, they do not form an AP. Okay, they do not form an AP, but we can use the results of AP to find out this sum. Okay, so for that let us observe. So what we do is we observe this r cube minus r minus 1 whole cube is what? If you just simplify it, r cube minus r minus 1 whole cube, if you simplify it, you will get this expression, right? R minus 1 whole cube can be written as r cube minus 3r square plus 3r minus 1. Okay, and then this r cube will get cancelled, and you will be left with 3r square minus 3r plus 1. Okay, and then what do? You put r equal to 1, 2, 3 up to n. Okay, successively. So if you put r equal to 1, you will get 1 cube minus 0 cube, right? If I put r equal to 1 in this expression, I will get 1 cube minus 0 cube on the left side. On the right side, I will get 3 into 1 square minus 3 into 1 plus 1. Okay, on the left side again, if you put r equal to 2, you will get 2 cube minus 1 cube. So that is 3 into 2 square minus 3 into 2 plus 1. Okay, so that way you keep on putting, and then we can add them up. So how many expressions are there? Here there are n expression exactly, right? And if you just observe, each of these terms will get cancelled. See, 1 cube cancels with minus 1 cube. This 2 cube will get cancelled with minus 2 cube, right? 3 cube will get cancelled with the next one. Okay, which one will not get cancelled? Only this 0 cube is not getting cancelled. N cube is not getting cancelled, because n cube has to get cancelled with the next one, but there is no next one here. Okay, this term will also get cancelled with the previous one. Okay, so everything is getting cancelled except n cube. So it's n cube on the left side, and on the right side you can just take 3 common. It's 1 square plus 2 square plus up to n square. This is 1 plus 2 plus up to n, and if you add 1 n times, then you will get the result as n. So the last term is n here. Okay, so this is just a little bit simplification. If you simplify this expression, you will be getting s equal to n into n plus 1 into twice n plus 1 by 6. This is the sum of the squares of first n natural numbers. Okay, so as an exercise, you may try finding out the sum of the cubes of first n natural numbers. Okay, you may try this. You may try writing this, finding out this one. 1 cube plus 2 cube, okay, plus 3 cube, right, plus dot dot dot. Okay, plus n cube. Okay, sum of the cubes of first n natural numbers. Okay, you please try it. Okay, where is this? Did I write? One cube plus 2 cube plus 3 cube plus L dots plus n cube. Okay, so you may try finding out this particular sum, okay, as an exercise. Right, this you can try doing it at home. Sorry, it is the select tool. Okay, try this as an exercise. 1 cube plus 2 cube plus 3 cube plus up to n cube. Okay, you will get a familiar expression. Okay, so I think you will have some idea about arithmetic progression. If possible, I'll also try to do 1 or 2 more problems of say PRMO standard related to arithmetic progressions. Okay, so till then, please go through this video and please join us for the lecture. Right, thank you.